September 1st, 1859. 11:18 in the morning. A man named Richard Carrington was watching the sun through a telescope when a blinding white flash exploded on its surface. It lasted 5 minutes. Then, it was gone. 17 hours later, something arrived at Earth. The sky caught fire. Auroras, the lights you usually only see near the North Pole, appeared over Cuba, over Hawaii, over the Bahamas. People read newspapers outside at midnight by the light of the sky. That was just the light show. The real damage was different. That was 1859. Now ask what happens when it happens again. Welcome to Infinitum Space. Here is what the sun actually did in 1859, and why it was so much worse than most people realize. The sun has a magnetic field. Think of it like Earth's magnetic field, except the sun's version is millions of times stronger. And it's alive. It moves. It twists. It builds pressure.
When that pressure gets too high, it snaps. That snap releases more energy than every nuclear weapon on Earth combined, all at once. And right behind the light, the sun fires a physical projectile. A cloud of charged particles, more than 1 billion tons of material, moving at up to 3 million miles per hour. We call it a coronal mass ejection. In 1859, that cloud was aimed at Earth. Earth has a magnetic shield, an invisible bubble that normally deflects solar particles. But the 1859 event was too big. The energy ripped through the shield and hit anything on the surface that could carry electricity. The result? Auroras seen at the equator for the first time in recorded history. And anything with a wire burned. Scientists rate solar storms from G1 to G5. The 1859 storm broke the scale. It had no rating because nothing like it had ever been measured. Scientists checked ice cores from Greenland, layers of ice that record every major solar event going back thousands of years. The 1859 storm left the biggest chemical mark in 500 years, and there is one older storm from the year 774 that may have been even larger. We have no idea what it did to the Earth, because humans in 774 had no wires, no electricity, nothing to burn. The sun was not trying to hurt anyone. It was just doing what the sun does. Now here is the part that actually matters. If a storm the size of 1859 hit Earth right now, in 2026, the damage would not be burned telegraph wires. It would be something far worse. Every power line on the planet would act like an antenna. Every transformer, the giant metal boxes that move electricity from power stations to your home, would get hit by a surge they were never built to handle. These transformers weigh up to 400 tons each. The United States alone has around 2,000 of them. They cannot be rushed. When one fails, it takes up to 18 months to replace. In a Carrington-level storm, hundreds would fail at once. The lights go out. Not for a few hours, not for a few weeks. Scientists estimate the power grid could be down for 4 to 10 years in a worst-case scenario. No power means no water treatment. The systems that make your tap water safe need electricity to run. No power means hospital backup generators run out of fuel in about 3 days. No power means GPS stops working properly. No power means the internet goes dark within days as data centers lose power one by one. Each thing that fails breaks something else. Water, hospitals, food supply chains, communications, financial systems. Not one disaster, a chain of disasters.
In 2026, based on updated assessments from NOAA and the European Space Agency, the estimated global economic damage from a storm this size sits between $2 and $5 trillion. That is not a worst-case fantasy. That is the current scientific estimate. Here is what makes this more than a history lesson. The Sun is not finished. The Sun runs on a cycle. Roughly every 11 years, it reaches peak activity. More flares, more CMEs, more chances for something to hit Earth. We hit the last peak in 2024. We are still inside the active phase right now in 2026.
The reason this keeps happening is simple. The Sun spins, but not all at once. The equator spins faster than the poles. This winds up the Sun's magnetic field like a rubber band. It twists. It tightens. Eventually, it snaps. Every time it snaps, a CME. The Sun fires these blasts in every direction. Most go into empty space, but Earth orbits the Sun. Eventually, the timing lines up. In July 2012, the Sun fired a blast that scientists measured as Carrington level, maybe larger. It missed Earth by 9 days. 9 days. Earth had already moved through that exact point in its orbit. If the CME had launched 9 days earlier, we would still be recovering today.
Scientists now estimate roughly a 10 to 12% chance of a Carrington-scale storm hitting Earth in any given decade. We are in that decade right now. The Sun does not know we are here. It does not aim. It does not warn. The question is not whether this happens again. In the past 200 years, the Sun has launched at least 10 storms powerful enough to affect Earth. It launched a near-extinction level one in 2012. It will launch another one.
There is one more thing. Earth's own magnetic shield has weakened by about 9% over the last 170 years, according to the European Space Agency's 2025 monitoring data. A weaker shield means the next big storm hits harder. We are more exposed than we were in 1859, and our civilization is more dependent on electricity than at any point in human history. As of 2026, there is no global system in place to harden every power grid against a storm this size. Some countries have started. Most have not. The window between detecting a CME and it reaching Earth is between 1 and 3 days. 1 to 3 days to prepare for the end of the electrical age. It has already fired at us once. We were lucky. We had almost nothing to destroy. The next time it fires, none of that will be true.